Fine. So in our today's session team, we discuss on circuit breaker. So let me share my screen to you. Are you able to see the screen, team? Yeah. Yes. Cool. So let's start the circuit breaker. So a circuit breaker is a mechanical switching device that can make or break the circuit. It seems that. So when I'm talking about the disconnector, I stated a point that the disconnector or isolator cannot be operated in load because it's not having it's not capable to break the circuit or make the circuit. So, but the circuit breakers or the devices, mechanical switching devices, having two contacts, a fixed contact and moving contact, which can the circuit breaker which can make or break the circuit in load condition. Not only normal conditions, in abnormal condition also. Under normal condition, circuit breaker can make, carry or break the circuits, and under abnormal conditions also, it can make or carry for a specific time and break the currents. So what is the principle behind this? How it is, how it can break or make the circuits? So every circuit breaker generally, so when I am opening the two contacts, there could be a chances of interruption of arc. So there should be a formation of arc. So I have to quench that arc. So to quench that arc, I should need a medium which should good at dielectric strength, such as oil, air, vacuum, SF6. So depend upon the voltage level and reliability perspective, the air circuit breakers are generally used in low voltage systems. Air circuit breaker in the sense, the medium which is quenching the arc, which is helping the breaker to quench the arc. That if I am using air, then it is a air circuit breaker. If I am using oil as a medium, oil circuit breaker. If I am using SF6 circuit breaker. And if I am using vacuum, it's results to vacuum circuit breaker. So 4 breakers we are having. So it depends upon the voltage level. Up to at a low voltage systems, generally air circuit breaker, ACBs, you can see for 415 volts systems. And if we go to 11 kV, 33 kV level, up to 33 kV level, you can find vacuum circuit breakers. In some 33 kV projects, they are using SF6. But mostly 33 kV is vacuum circuit breakers. And the third one is oil. Oil is present not using at all because of leakage, everything, but it is violated. So next one is the SF6. So above 33 kV level, all the breakers for all remaining voltage levels above 33 kV are of SF6, which is SF6 gas, which is having a high electronegativity nature. So if I am talking what the functionality of the breaker, characteristics of a breaker, the breaker, it can make or break a circuit under normal conditions, either manually or using a remote control. Similar, same statement. What when I am discussing about the disconnector operation, same applied here. Under abnormal or fault conditions, it can break the circuit automatically. And the third one is it can make the circuit under fault conditions either manually or using remote again. So both two operations are there at every stage, for not only for the breaker, for the for isolator as well as for the isolator breakers, we are having two modes of operation. One is local mode, other one is the remote location. From remote, I am operating the breaker. From local one. So let's go in deep in the breaker. So before going into this, again, when we are talking about these equipments, we have to keep in the mind that, so what are the parameters much required to brief the requirement of the breaker? So we have to give some requirement of my breaker to the manufacturer. So for that, you cannot explain each and every part of the breaker. So we will give a glance, an overview of the breaker by this main parameters. The design, the manufacturer can understood, oh, what type of this X type of breaker he's asking. So what are the main parameters that we need to specify when we are preparing the bill of material or bill of quantities for our projects? And again, in addition to this, definitely we will enclose the technical specification of the breaker to it. In that, there is some deep depth, the literature or explanation of the breaker will be in depth. Each and everything, what are the type tests to be conducted, how to be conducted, and what are the IEEE standards or IES standards we have to comply on this. So everything will specified in the technical specification. So every manufacturer cannot read the technical specification when you're asking for the price. So he has to look on main parameters, so that we have to specify. That's come under in our next slide, which is this parameter selection and sizing. So these are the main parameters we need to specify for the breaker. In this also, we not required to specify closing time, opening time, first pole to clear factor. These things are again not required. And just, but in my view, I felt that those are some important parameters. That's the reason I included those also in this. Apart from this, we are having some other parameters like rated rated capacitor breaking currents or line charging currents, and other conditions which are rated short time withstand current when you are operating this capacitor banks or series reactors or shunt reactors, and transmission line charging, as well as TRVs, transient recovery voltages. So these are some other parameters are there. Those are additional, which are not mandatory. Those will come as a project specific. So again, you are not doing any calculation further. Just you are specifying that I require a breaker for switching off the my reactor or capacitor banks. Fine. So in this, I think we already discussed about the rated voltage as well as the rated current. Rated current here similar to the isolator stream. So we are having only few ratings of the current ratings for the breakers. So we have to opt only from this list. These are all from this is constant for all the manufacturers across the global. On frequency, 50 Hz. Number of poles is how many number of poles will come. Type of a breaker. I mean that if my breaker is a gang operated breaker. We are having two types of breakers. One is a gang operating breaker. Other one is a individual pole operated breaker. What the meaning of gang operated or pole operated is, see, I am having three phases R, Y, B. So when I open the breaker, if R, Y, B opening at the same time, so I can call it as a gang operated breaker. Means if a fault occurred on the R phase, R, Y, B phase, all three phases will trip. The breakers of these three phases will open in a gang operated. Means if any one of the pole is operating, pole here nothing but phase. If one of the pole is operating, all the other two poles will also be operated in a gang operation. In a gang operation. Come to the next one, which is an individual pole operation. In individual pole operations, we are having three poles, R, Y, B. Here, each one is operating in a separate. Suppose if a fault occurred in the R phase, so R phase breaker will only trips, and if a fault occurs on the Y phase breaker only trips. So why I required this? I am losing some unbalanced. If one of the phase is not there, exists in the system, it results to the unbalanced loads. So we already know this, but why I am opting for this? Because in the transmission lines, generally the transient faults are permanent temporary faults are generally 80 to 90%. The only 10% of faults are permanent faults. Remaining all are transient faults. So these are exist only for few seconds, not seconds also. Just a tree hitting the branch, hitting the conductor and going away. So what it's coming and connecting to my phase and going. So it's like a temporary fault. So for this, I should not interrupt the entire system. So I will adopt some kind of technology, some kind of functionality called auto reclosure. We will see that in the next points. So for that functionality, only that pole has to be operated for which the fault has occurred. That pole is operating, and I am again closing that. Let's see that in the next topic. So for time being,